Anyone have a preference? Any on the first page? Number 7 and 8 shouldn't have been super wonderful. Or maybe you guys got them figured out and they were easy. 7 and 8, were those okay? Those were like what we did yesterday? Those were good? Okay. Ah, so they weren't as bad as we thought, huh? Okay, so first page is not bad. We're okay with first page? Even a problem like number 2? How'd number 2 go? So no help on the first page. Not even number 5, that one was real hard. No? All right. First page is set. Second page? Number 10 maybe? Do 10? Okay, let's do 10. 10 and 14, we can do 10. Oh, 14's not too bad. Okay. Let's do number 10 though. For sure number 10 is a good one. Okay, so for number 10, what do we do first? Are you guys using the flowcharts? Do you need them? The little half sheet I used last night in the video. It like helps you think through which type of problem it is. Some people need it, some people might not. Have we been using it? Do you want me to show using it to do the problems? Yes? Okay. Let me find my flowchart. So on the flowchart, we first ask ourselves, are there logs in the problem? So for number 10, are there logs in the problem? Yes. Okay, so that means that we are doing a logarithmic equation. We have to do our properties of logs to condense it so there's only one log per side. Okay? The right side has no logs. The left side has 2. So how do we condense it down? Yes. So we have log base 2, and we have a division problem. So what should I be writing? Perfect. Okay. So minus means a division problem. We have log base 2, y plus 2 over y minus 2 equals 1. Now when we look at the flow chart, it says, is the log on one side or both sides? It's on one side, okay? So you can Tootsie Roll to turn it into exponential form, or you can exponentiate both sides, okay? Do you guys like Tootsie Rolling, or do you like the idea of doing the inverse on each side to undo the log? Okay, so if we were to Tootsie Roll, we would say let's start with the base of 2, and we would do 2 to the first equals the fraction, right? If we do the method where we think about exponentiating, we would say log base 2, the opposite of that is an exponential function with a base of 2, so exponential function with a base of 2. And I would say my log base 2 and my exponential with the base of 2 cancel out. And so then I would have y plus 2 over y minus 2 equals 2 to the first power. So I get the same thing, just depends on how I think about the problem. Okay, what's 2 to the first power? 2? Okay, so I don't really need that exponent of 1 because 2 to the first is just 2. What could I do to make that not a fraction anymore on the left side? So you could think about it as like I'm taking this whole group and I'm multiplying it over to the right side. If you want, you can think about putting a 1 underneath this and cross multiplying. 2 different ways to do the exact same thing, okay? So if I think about cross multiplying, I would say y plus 2 equals 2 times y minus 2, which is exactly what you would get if you take that bottom part and multiply it over to the right. Okay, so at this point, what could I do to finish the problem? Or do more of the problem, I guess. Yeah, I can distribute that too. So I have y plus 2 equals 2y minus 4. You could. So what I usually do next is get the variables to one side. Okay. so we can minus 2y. So that would give us negative y plus 2 equals negative 4. And then we would minus the 2 over. Negative y equals negative 6. So if negative y equals negative 6, positive y equals positive 6. And before I box my answer, what do? I double check. I want to make sure that when I plug in 6, I'm not taking the log of 0 or taking the log of a negative. So 6 plus 2 is 8. I can take the log of 8. 6 minus 2 is 4. I can take the log of 4. So both of those are good, and that means that this is a solution. All right. Is there another one? There's lots of E problems on this page. Should we do an E problem? Yes. Okay, which E problem?
12.
We got 12, we got 18. Maybe we should do 18? 18's a little bit worse, I think. Do 18. Okay. So for 18, we want to start moving stuff away from the X. What is something we could easily move? The 4. How do we move it? Subtract. So 21 minus 4 is 21 minus 4, 17. Good. So if we look at the chart, there are no logs in the problem, so this is an exponential problem. I cannot get the same base. One side has an E, the other side has a 17. So that means I need to Tootsie Roll or I need to log both sides. So I can think about this as exponential form is not helping me, so I'm going to convert it into log form. Or you can think of it as I need to undo the base of the exponent to get the exponent where I can get to it, I guess. So do you guys want to Tootsie Roll or do you want to log both sides? Log? Tootsie Roll? Either one? So if we log both sides, what type of log do we do to get rid of a base E? ln, so we can ln each side. ln and E are inverse operations, so they cancel each other out. And that gives me x minus 2 equals ln of 17. And then what do you do? Add the 2 over. Do you add it to the 17? No. So the 17 got ln'd, that means that there's technically parentheses right there, and the plus 2 is just on the end. So this is our exact answer. I can't remember if the instructions want you to round or not. Yep, round to 3 decimal places. So that means we need to type it in our calculator and see what decimal we get. Do you have to check exponential equations for extraneous solutions? Are there certain numbers that an exponential function is not allowed to have? No, you do not have to check exponential functions. So these ones, any answer is good. Yeah. Let me know when it comes to you, okay?
Oh, for the thing when we have the paper that says the different,
Oh, the chart?
Yeah.
Yeah. Say it again. What was your question about it?
Oh, yeah. Will we have that on the,
In an assessment situation, I would not give that to you. The idea is, though, if you've done those problems, you've noticed that those numbers are pretty repetitive. Like if you looked at this one, can you already tell me what the bases would be? 127th and 9? 3, right? You know so because those numbers there's not like a ton of them, usually what I do is I give students the chart when they first start learning it because it makes it a little bit easier to like locate the numbers. By the time you take this sort of thing in a testing situation, if you can't remember what negative exponent that is, you could like type it in a calculator real quick and you know what I'm saying? Like it's something where you don't necessarily need the whole chart anymore. Yeah. I don't want to give you guys the chart because I think if I give it to you all the time, it's a crutch and you don't realize that you do kind of know those numbers and you're definitely not going to get it on the exam. So if you want to put the chart on your cheat sheet, that's totally fine, absolutely fine, so that in a pinch you have it, but I wouldn't give it to you for just the entire assessment. Okay. All right. Any questions on the next page you already are feeling like maybe would be good to go over? Yeah. All right, this is definitely a log equation, right? So when we look at the steps for a log equation, first thing we got to make sure that we condense it because we're only allowed to have one log on each side. So my most common mistake is students see all those ln's and they go cancel, cancel, cancel. You cannot do that. And the reason that you can't do that is because you canceled two things on the left side, but you only canceled one thing on the right side. Is that equal? No. So you didn't do the same thing to the left side of the equation and the right side of the equation. Also, what does that minus really mean? Does it mean minus? No, it means not multiply. Divide. Yeah, so that means that if you did cancel the logs, you'd be making this a subtraction problem when it should be a division problem. All right, so be careful about that. So ln, this is a division problem, so we have x plus 3 over 2x minus 4 equals ln of 3. So I have to use my properties first. Then I can go to the next step, which is to see if it's on one side or both sides. This is both sides, so what do? Ditch the logs. We can get rid of them. So x plus 3 over 2x minus 4 equals 3. So this is one of those problems where if you want, you can put it over a 1 so you can cross multiply, if that feels comfortable. Or you can take this chunk that's on the bottom and multiply it to the other side. Okay? So what we would have next is x plus 3 equals 3 times 2x minus 4. And what do we do after that? Distribute. So we have x plus 3 equals 6x minus 12. Okay. What do you guys want to do next here? Subtract the 3. Okay. So we're going to have x all by itself equals 6x, and if you have negative 12 and you subtract 3, negative 15, okay? Oh. Then what do? We can't divide yet. Get the x's to one side. So how are we going to get the x's to one side? Subtract the 6x over here. So 1x minus 6x is negative 5x, okay? And then x equals 3. Right, negative 15 divided by negative 5, which would be 3. So before we box our answer, we want to check it. So 3 plus 3 is positive, and I can take the ln of a positive. 2 times 3 minus 4 is still positive, so we're still good. All right. I was thinking it might be good, even though I got a lot of nods for 7 and 8 that they were okay, maybe let's go over 1 just in case people had a hard time yesterday but don't want to say it. So would you guys rather do 7 or 8? They're very similar. Number 7 it is. Marvelous. All right. For number 7, what is our very first step when we see an exponential problem like that, where the bases cannot be the same, and you have bases with exponents on both sides? What's the first step? So change it into logs. Can we do Tootsie Roll in these problems? No, because there's 2 different bases, yeah. So So for this problem, this is where we don't do a log with the base. We typically log each side or we ln each side. It doesn't matter. Which one would you guys rather do? Log. You're very quiet. I'm wondering if maybe we should do one like this that's later on in the packet. Maybe one you haven't done yet. Would that be better? Yeah? Okay. So maybe let's do, like, have you guys gotten to 35? 35 is like this. 36 is like this. 36 is kind of a good one because we got a fraction in there. Okay, 36. All right. So same thing. We're going to go ahead and log each side. We said we want to use log. So I'm going to do log 6 of x plus 16 equals log 7, not of x plus 16, to the x plus 16. And this is log 7 to the x divided by 4. And once we log each side, what do we do with those exponents? Bring them to the front. Okay, so we have x plus 16 log 6 equals x divided by 4 log 7. Instead of writing this as x divided by 4, because I don't really like that division, I'm going to go ahead and call this 1/4 x. Or do you guys want to call it 0.25x? 0.25x? Okay, so we'll do right here, x dividing, when you divide an x by 4, it's the same thing as taking 1/4 of it. And if we would rather have a decimal than a fraction, we can call that 0.25x. So that's what happened. I'm going to go ahead and write this, that x over 4 is the same thing as 0.25x. I just rewrote it like that. Okay. At this point, what do I want to do? Has to do with the parentheses. Distribute. I don't want those parentheses anymore. So I'm going to say x log 6 plus 16 log 6 equals 0.25x log 7. And then what should I do? Yeah, I want the variables to be on one side. So right now I've got an x here and an x over here. Do you guys want to move them all to the left side or all to the right side? To the left side? Okay, so if we do that, that means we're going to take this one and we're going to subtract it over to the left. So I'm going to keep the x log 6, and then I'm subtracting over 0.25x log 7. And I only want the ones with the x's on the left side, so that means that this one, I'm going to go ahead and move over to the right side. So now I'm going to go ahead and take this and minus it over here. So negative 16 log 6. Okay. What do I do next? Take out the x. So I've got log 6 minus 0.25 log 7. Divide the whole parenthesis. Okay, so x equals negative 16 log 6 divided by log 6 minus 0.25 log 7. And that is ready to plug into a calculator. And then remember, if you had done the same problem and you used LNs instead of logs, you still would have gotten the same answer. See? So logs and ln's both give the same answer. It just comes down to which one you want to write as you do your work. All right, what's another problem we should do? What did you say? 44? All right. So we look at 44. It's a log problem, right? We have to do our properties to make sure we only have one log per side. Do we need to do anything for that? Multiply them, right? So we have ln of x being multiplied by 3x. What is x times 3x? 3x squared. So I have ln of 3x squared equals 12. So with the log problem, I have a log only on one side. I can Tootsie Roll or I can exponentiate to get rid of the logs. Okay? So what base do we use to get rid of an ln? An e. All right? So if I were to exponentiate, I would put a base of an exponent on the left side and the base of an exponent on the right side. So this is e to the 12th. This is e to the ln of 3x squared. The e and the ln cancel, and we have 3x squared equals e to the 12. And then what do we do? Divide by 3. So x squared equals e to the 12th over 3. And then what do we do? Square root. This was a good one. It's harder than it looks. X equals square root of e to the 12 over 3. And what should I put in front of my square root? Plus or minus? No dead ducks here. Okay. Do we box those answers and call them good? No. What do? We have to check them. Let's go ahead and figure out what that decimal would be. So I have a square root. I have a fraction. Second ln, so that's my e to the 12 over 3. Okay. So I have x is approximately positive or negative 232.919 has to be rounded up. How do I round up 919? 920. Okay. If I plug in positive 232, is that good? ln of positive 232. ln of 3 times positive 232. Still good, still positive. If I plug in negative 232, am I going to be okay? No, it's not going to work. So that means that I can't use both of those answers. I only get the positive one. It appears so, yes. The equal button is also the plus button, and so I'm guessing that should have been a plus. Is there another one we should do? I mean, you can do all the problems yourself if you want, but I could do some for you. 48. Yeah. Let's start at the end and work our way backwards.
Yeah.
All right. So 48. It's a log equation. Lots and lots of logs in there. So what do we do first with log equations? Condense. There can only be one log per side. So I've got log base 6. Okay. Do you guys want to FOIL now, or do you want to wait and FOIL after we get rid of the logs? Just wait? Okay. So we have logs on both sides. Cancel them. All right. So now we can go ahead and FOIL. What do you get if you FOIL out x plus 3, x plus 2? Subtract the 20, it's got to equal 0. So 6 minus 20. Negative 14. So we're choosing two numbers that multiply to negative 14 but add to positive 5. X minus 2, x plus 7. So two solutions, and what are they? Positive 2 and negative 7. Do we box them both? No. Which one doesn't get boxed? Negative 7. So if you look at the negative 7, if you tried to plug it in right here, negative 7 plus 3 is negative 4, and you can't take log of negative 4. Negative 7 plus 2 is also a negative, and so negative 7 just really doesn't work. Positive 2 is good, because you still have positives when you plug it in. Okay. How far have we gotten in the packet? Like, we all should have done the first page. Should we all have done the second page? Yes? So 1 through 18, everyone definitely did that. How did we do on the third page? Oh, you've been skipping around. So how many problems do we think? We got 5 minutes of class left. How many problems do we think is fair out of the whole packet? There were 48 problems total. How many do we think is fair to need to have done? So like 30 problems total?
Yes. She said 30. I'm thinking 30.
Well, that got awkward. Like, where are we at? Okay, so if we get 30 problems done, that means if you skipped some, you're going to have to go back and do them, right? So 1 through 30 will be the actual assignment if you choose to do more than that extra credit. Reasonable?